Hello students, I am Subhashish. In our previous session, we have learnt about the zeros of a polynomial. In this session, you will learn about factorization. Learning outcomes. After completion of this session, you will be able to understand the factor theorem and its significance in polynomial factorization. Identify factors of polynomials using factor theorem. Polynomial factorization through splitting the middle term. Keywords: polynomial, factorization, factor theorem, zeros of a polynomial, linear polynomial, remainder theorem. Students, let us recall the topic of polynomial and its zeros so that we will understand our today's topic, factorization. A linear polynomial of the form ax plus b will have the zero of the form x equal to minus b by a. A linear polynomial has one and only one zero. A polynomial can have at most number of zeros that are equal to the degree of the polynomial. Now, let us recall the statements of remainder theorem and factor theorem which we have read in our previous session, so that now we can prove the factor theorem. Remainder theorem. The remainder theorem states that when a polynomial p of x is divided by a linear polynomial x minus a, then the remainder is equal to p of a. The factor theorem states that x minus a is a factor of p of x if and only if p of a is equal to 0. We have learned to find zeros of a linear polynomial by equating it to 0 and learned to find zeros of quadratic polynomial by substitution. Let us see the zeros of a polynomial by factorization. Before learning factorization, we will learn the theorem of the factors, which is factor theorem. Now, let us learn the statement and proof of factor theorem. If p of x is a polynomial of degree n greater than or equal to 1 and a is a real number, then x minus a is a factor of p of x if p of a is equal to 0. P of a is equal to 0 if x minus a is a factor of p of x. Proof. By the remainder theorem, p of x is equal to x minus a into q of x plus p of a. If p of a is equal to 0, then p of x is equal to x minus a into q of x, which shows that x minus a is a factor of p of x. Since x minus a is a factor of p of x is equal to x minus a into g of x for the same polynomial g of x. In this case, p of a is equal to a minus a into g of a, which is equal to 0. By the proof of factor theorem, we understood the substitution of factor makes the polynomial value 0. Let us see some examples to understand and learn the theorem. Example. Examine whether x plus 4 is a factor of 2x cubed plus 17x square plus 46x plus 40 and of 4x plus 7. Solution. The 0 of x plus 4 is equal to x equal to minus 4. Let p of x is equal to 2x cubed plus 17x square plus 46x plus 40 and s of x is equal to 4x plus 7. Now substitute the x value in p of x, then we get p of minus 4 is equal to 2 into minus 4 whole cube plus 17 into minus 4 square plus 46 into minus 4 plus 40. Then after multiplying we get minus 128 plus 272 minus 184 plus 40. After solving we get it as 0. So by the factor theorem, x plus 4 is a factor of 2x cube plus 17x square plus 46x plus 40. Now substitute the x value in s of x, then we get s of minus 4 is equal to 4 into of minus 4 plus 7. Then after multiplying we get minus 16 plus 7. Then we get minus 9. So x plus 4 is not a factor of 4x plus 7. Let us see another example. Find the value of k if 2x minus 3 is a factor of 4x cube plus 8x square minus 15x minus k. Solution. As 2x minus 3 is a factor of p of x is equal to 4x cube plus 8x square minus 15x minus k. So we can say 2x minus 3 is equal to 0. We get x equal to 3 by 2. Now substitute x value, that is 3 by 2, in the p of x to get the k value. P of 3 by 2 is equal to 4 into 3 by 2 whole cube plus 8 into 3 by 2 whole square minus 15 into 3 by 2 minus k. If p of 3 by 2 is equal to 0, we equate the p of x to 0. After solving, we get 27 by 2 plus 18 minus 45 by 2 is equal to k. For solving k, we get 18 minus 18 by 2, which is equal to 18 by 2. By cancellation, we get k equal to 9. Now we will use factorization method to solve the polynomial of degree 2. We already know how to factorize a quadratic polynomial. We split the middle term and now we will learn the general procedure of splitting or factorizing. Generalized factorization of polynomials. Let us consider the polynomial ax square plus bx plus c, which is equal to px plus q into rx plus s. By multiplying the factors, we get prx square plus p into s plus q into r into x plus q into s. So, by comparing the coefficients of x square, we can say that pr is equal to a. Similarly, by comparing the coefficients of x, we get b equal to ps plus qr. and on comparing the constant terms, we get C equal to Q into S. This shows us that B is the sum of two numbers, PS and QR, whose product is P into S into Q into R is equal to PR into Q into S, which is equal to A into C. Let us look into another example. Factorize u square minus 5u minus 36 by using factor theorem. Solution. Consider u square minus 5u minus 36 is equal to p of u. If a comma b are zeros of p of u, then u square minus 5u minus 36 can be written as u minus a into u minus b. So, ab is equal to minus 36. Let us look at some possibilities where the pair of products will be equal to AB, which is minus 36. From the following pairs, we select P of minus 4, which is equal to minus 4 square minus 5 into minus 4 minus 36, which is equal to 0. So, u plus 4 is a factor of P of u. Similarly, we can find P of 9 is equal to 9 square minus 5 into 9 minus 36, which is equal to 0. So, u minus 9 is a factor of P of u. Substitute minus 4 and 9 in place of a and b respectively. Then we get P of u is equal to u plus 4 into u minus 9. We have to note that P of u can also be factorized by splitting the middle term. So, by these examples, we have learned to factorize by using the factor theorem as well as splitting method. Points to remember. The degree of a polynomial determines the maximum number of zeros it can have. Factor theorem. X minus a is a factor of the polynomial p of x if p of a is equal to 0. Also, if x minus a is a factor of p of a is equal to 0. The factor theorem can be proved using the remainder theorem, which states that when a polynomial p of x is divided by x minus a, the remainder is p of a. Thanks for watching.